your slides perfectly.
Okay, super. Super. Yeah. So thank you very much, Jan, for the invitation to speak here. And I know Barend was there earlier this morning. So maybe you get a second dose of a Go Fair point of view again. And by the way, I've been, although I wasn't attending online throughout the day, I've been hearing some very nice commentary in the background about from Barend and also from Martin's talk. So congratulations, I think, on a very nice set of presentations today. So I am, for about 5 or 6 years now, full-time at the Go Fair Foundation. We're located in Leiden, but we're an organization that has kind of an international perspective. Quite recently now, I've rejoined the academic environment here in Leiden as well. So I have an appointment now at the Leiden Academic Center for Drug Research, and I hope to take back with me some of the things we've learned in Go Fair into a research role again here at the university. Just so you know, my background is in biomedical research, and I've done also very kind of data intensive research like text mining and exploring new formats like nano publications, et cetera. But I've been in Leiden, and we've seen FAIR from the beginning over here, so it's been an exciting ride. The overall discussion then for today is basically talking about having FAIR principles on one side, very high level statements about behaviors that would be needed or expected in order to automate the FA, I, and R functions, and then also the translation then of those principles into actual concrete implementations. And that's been the mandate of Go Fair from the beginning. And so Jan wanted to hear more about some of the work we've done at metadata for machine workshops and FAIR implementation profiles. So I can tell you briefly a little bit about what we've done in that regard. I want to do some acknowledgements at the beginning because there's never or oftentimes not enough time at the end to do this, but some of the work I'm going to talk about today has been in projects that we've had with both the ENVI-FAIR program and also with CoData. And the people listed here are key contributors to the things I would like to present to you today. So I always will begin, being Go Fair, we always go right back to the very beginning. This was the original, let's say, peer-reviewed enunciation of the FAIR principles that appeared in 2016 in the original paper on this. Nothing was mentioned in that paper except this figure item, box 2, which gave these 15 one-liners that, again, we would hope that for systems that could adhere to these principles, that in fact, F, A, I, and R could be more and more automated, and that humans would not have to be in the loop manually data munging in order to actualize the F, A, I, and R. And I just wanted to highlight a few high-level things about the FAIR principles. It's nice, I think, to point out that metadata is everywhere in the FAIR principles, and that indeed metadata has become a first-class citizen along with data itself. And it's really the metadata and the machine actionable metadata that would help to instruct agents to actually perform these FAIR operations that we envision. Although the split is not complete, I think we can at least try to partition roughly the FAIR principles into 2 categories. The first category I would call this technical infrastructure. These are principles that would refer to technical implementations that would, in principle anyways, be generic. And these would be generic services that could be operating on data. And domain experts would maybe have very little or very, very soft opinions about what these technical infrastructure elements might look like. And in fact, that's in contrast to what we might call the social decisions or the domain-specific agreements that need to happen if fair is to be realized. So it's just nice to point out that in realizing fair and getting to fair implementations, we oftentimes will need to work with stakeholders that have a very much more technical background and are thinking about general infrastructure issues, as well as, say, practicing scientists or engineers who have a very strong opinion in that case about the vocabularies and the terminologies and data practices, et cetera. So we need information from both these groups in order to realize the FAIR principles into concrete implementations. And I think the discussion yesterday, today, and tomorrow is focusing primarily on 3 principles in particular. I2 is asking for vocabularies that themselves follow the FAIR principles, or are themselves findable, accessible, encouraging interoperation, and are reusable. So there's kind of this interesting recursive nature to the FAIR principles, at least in I2. R1.2, I want to highlight, and I'll mention this more at the very end of the presentation, but there's a lot of interest now and a lot of excitement around Chat GPT and other AI systems. And we see, at least in Go Fair, a bright signal on the radar now about the role of detailed and machine actionable provenance information, such that the synthesized information that we get from an artificial intelligence system, that we have some way of believing it and being able to establish some level of trust behind what AI systems are producing. And we think that will depend on FAIR data in general, but R1.2 in particular. So we see that as an important and very current development. And I just wanted to point out R1.3, which is, I love R1.3 because it's the only principle that has the word community actually here. So I'm glad to see that community made it into the FAIR principles. And it's asking for domain relevant community standards. So again, that's a call out to the domain researchers, the engineers, the scientists who are actually practicing the craft. It's only these people who have the current vocabulary, lingua franca, that we need to embed in the vocabularies and the metadata and data formats, et cetera, that will constitute the FAIR data. So that's just kind of a high-level overview, just a reminder again of the FAIR principles are pretty explicit, pretty concrete. And we knew already by 2018 that the translation from these high-level principles into implementations is where things will get potentially more complicated and will require some level of coordination and support in order to kind of accelerate that process to widespread FAIR implementations. And by 2023, so what, 5 years later, 6 years later, in the Go Fair Foundation, we've been refining better and better based on our experience with a broad spectrum of stakeholders, both in the public sector and in the private sector, some criteria and some supporting ideas about how FAIR can be implemented and what those implementations can look like to be highly effective. So we have this idea of these criteria at the Go Fair Foundation, and you can link to them. But one of the things we would like to focus on in Go Fair, above and beyond the FAIR principles themselves, is kind of an openness to decentralized approaches. So we sort of take decentralized architectures as the default, and then that some more centralized approaches are certainly welcomed when they're fit to a purpose. And then the same for open and closed, or say open and restricted data. As a default, Go Fair promotes a very open approach, but realizing that not all data can be made open. There's this possibility for restricted protocols as necessary. And then also we really also like to promote a kind of hourglass architecture approach or minimal standards, such that we could hope to avoid potential vendor lock-in on any kind of proprietary, say, data formats or software applications that would tend to gobble up the marketplace. So we would like to, in addition to the FAIR principles themselves, sort of have an approach that kind of guarantees and preserves this no vendor lock-in aspect. And you'll see that in the next few slides coming back. And that was all sort of by way of introduction. I think what Yann really wanted to hear from GoFair today was this idea about metadata for machine workshops and FAIR implementation profiles. This is part of an overall framework that's emerged in GoFair. We call it the 3-point verification framework. It's a very uninspired name because there's basically 3 elements to this. It's not the only way to go fair. It's not the best way to go fair, but the claim would be that for any attempt at verification, maybe even what you heard from Martin earlier this morning in the Roche context, I would claim that any verification process will consider at some point these 3 aspects. So in the context of GoFair, working with lots of stakeholders, we were able to kind of consolidate a lot of different activities and a lot of different technical aspects into this very simple 3-point verification framework. And the next couple of slides, I can try to introduce you to the first 2 of these in some detail. And also to mention, before I actually talk about M for M's, this is a slide indicating that there has been quite some broad interest and uptake on this 3-point verification framework. So I think we've proven to ourselves that this framework, this way of looking at the problem, is a handy way to do it. It's gotten some traction in the broader community. We started doing this with our local Dutch organizations, ZoneMV, Health RI, and Health Holland. But then it was very quickly adopted internationally. So we have projects going on, for example, with GloPidR, which is an association of funders that are, in this case, trying to track funding that's in response to pandemics and trying to make that more streamlined using FAIR data. We've done a lot of work with the EnryFair community, and we've been working very closely with them for about 4 years now, working with the 3-point verification framework. The World Fair project from CODATA is very broadly interested in cross-domain interoperability and is using the FAIR implementation profile for that. The most recent work we're doing now with this partnership, the Partnership in Chemical Risk Assessment for Europe, a very large project, 400 million over 7 years, to verify for 23 European countries the information related to chemical risk assessment. And we're actually involved as GoFair in a pretty deep training program right now to help people actually learn to deliver M4M workshops and FAIR implementation profile workshops. And we also have some work coming up with the NIH in the US, and you can link to that here. So it's to say that the framework itself has some traction, and as we progress down this, I think we get, we refine the techniques and the methods, the technology, so that it becomes more effective. But here's an introduction to the idea of this metadata for machine workshop. And it started because we realized that metadata was all over the FAIR principles. And as a scientist, I am aware of, and I think it's no secret, that a lot of practicing researchers know very little about metadata in general, and probably even less about machine actionable metadata. So we knew in GoFair that we would have to have probably some support structure, a workshop format, some resources that can help organizations to boot up their FAIR metadata practices and kind of get them on the road so they can get more experience with what FAIR looks like and what it means for them. So we have this workshop format. There's different styles of workshops, but the format is always the same. We have domain experts. We have metadata experts who know something about FAIR. And the goal is, by the end of the workshop, that we have FAIR metadata products coming out the other side. And that means primarily that there are machine actionable schema and controlled vocabularies that are meaningful for these domain experts. And when we say domain experts, I think of the blue principles. These are the researchers who are actually practicing a craft. They will bring the domain relevant community standards. We need these people in the workshops to do our 1.3. The FAIR metadata experts are people who would have experience with a palette of solutions serving FAIR metadata, tooling to help you craft FAIR metadata, et cetera. And I'm sure a lot of what you've been discussing in the workshop yesterday and today, there's a lot of very nice solutions that we could bring into the M4M format, which is to say, you could think of the M4M as a kind of a vehicle for the delivery of good metadata solutions. So we can bring that in. And the idea is then that in reality, since COVID has taken up a lot of time, most of these workshops are happening online. So, you can think of a Zoom call. We have a few experts who come in with some solutions more or less customized to the particular needs of these domain experts. But by the end of the workshop, after a day or two, there's the first extensible, machine actionable, FAIR metadata that these researchers can have and work with. These workshops, all technology aside, and I should say, in GoFair, in metadata for machine workshops, we are technology agnostic, although we do have to, in any particular case, we choose technologies to work with. But what we really want to see in these workshops is not necessarily a technology solution. What we want to see are community level decisions that are required in order to create the FAIR data and metadata. It's really this R 1.3 aspect. Here's an example of a metadata for machine workshop, or a series of workshops we ran for our local Dutch funder, ZoneMV. This was in the COVID-19 program. I think in the end it was a 52 million euro program, 3 years. There was 130 projects selected, all COVID related, obviously. And collectively in these workshops, what this program created were 3 metadata templates. The first one was the project level administrative metadata. And this was actually kind of an interface to the funder itself. So it's really the connection point between the research organization and the funding organization. There was another template about the project content metadata. So this was really just a high level scientific description of the research project. So for example, there were projects that were doing socioeconomic research in COVID. And they would list, for example, that they were working with surveys as an experimental instrument, that these surveys had certain file formats, et cetera. That could be explained in the project content. And then there was another set of templates. We called it the generic data set template, based primarily on the data catalog, if you're familiar with that. But the idea was that for each and every data set created in a project, that data set could be linked to through its own metadata record. And I'm showing here this idea that the data could be distributed or decentralized in its storage, but these metadata are linking to them wherever they may happen to be. So you see kind of project level description and then data set level description. And this was the outcome of this community, the Zonenweg COVID-19 program community. This is how they chose to organize their data and metadata. And of course, along the way, we were careful to try and reuse existing vocabularies and existing metadata components as much as possible. And this information is now available through Health RI portal. And yeah, there's additional research going on now to try and increase the machine actionability, or try to make this metadata even more highly available in a FAIR context. But we were very happy to see that domain researchers could work together to create a fairly complicated metadata description of their resources. In addition to Zonenweg, there's been a lot of other work we've done. So we've delivered now 23 metadata for machine workshops. All of these are published on the Open Science Framework, and you can get to all this information. We typically use BioPortal as a way to register our vocabularies, and we oftentimes are using CDAR Workbench and CDAR templates as a mechanism of capturing the metadata. So that's a kind of an overview of M4Ms. We've done this for private sector, for public sector, and I think it's proven itself to be a nice kind of kickstart to groups that maybe don't have a lot of experience with metadata. I think for more advanced groups, we might have still something to offer at the metadata for machine workshop level. But I think for very advanced groups, these are problems that maybe they've learned to solve for themselves. For example, like maybe what you heard from Martin today at Roche. The FAIR implementation profile idea is actually quite closely connected to M4Ms, but is much broader in its scope. So a FAIR implementation profile is an idea that comes from the idea that if you have somehow successfully implemented FAIR data and services, it should be possible retrospectively to go back and say, well, what then is the technical implementation of principle F1, global unique persistent identifiers? What are my identifier systems that I'm using? Or for example, for F2, metadata for findability. Well, okay, what are the schemas I'm using? What are the vocabularies I'm using? So you could go through each of the FAIR principles, and you could describe in very precise and technical ways the implementations that you've used to realize those FAIR principles. So a FAIR implementation profile is just a list of what we call FAIR enabling resources that are delivering on those FAIR principles, and that each and every community, or let's say each and every implementation, would have a list, a unique list. Again, there's a lot of community decision making going on here. So how do we want to do, what kind of identifier systems do we want to work with? Yeah, who makes that decision, and how do we come to agreements on that technology choice? A way to begin to help communities to start formulating their FAIR implementation profile, it's primarily through a kind of a questionnaire approach. What I'm showing here is a link to a very abbreviated questionnaire that we've formulated for each of the FAIR principles. There's a question about the FAIR enabling resource that allows you to realize that FAIR principle. And there's a lot of engineering or a lot of careful thought that goes into the framing of these questions and the wording of these questions. But over time, we've gotten very good now at asking very precise questions to try and elicit the answers that are going to be most meaningful for a FAIR implementation profile. And by the way, if you happen to take a metadata from Machine Workshop and you then created FAIR metadata schema, FAIR vocabularies, these can be FAIR enabling resources that you could list in your FAIR implementation profile. So that's the connection between the M4M and the FIPS. The FIP is really kind of a broader view on FAIR implementation, where M4Ms are really focused on the metadata. There's a diagram here. We don't have to go into the complexity here, but it's just a reminder for me to say that this abbreviated FIP questionnaire is realized in a much more detailed and much more high precision way in a tool that we call the Fair Implementation Profile Wizard. And what we did is we commandeered the Data Stewardship Wizard, if you're familiar with that tool. We built a new knowledge model specific to the FIP questionnaire. And as a community might go through the FIP Wizard and answer questions, they are building up, using nanopublication technology, they're building up a fair implementation profile that is itself, I think, at a very high level, fair data. And when we have lots of communities generating these machine actionable FIPs, it allows us to come back then later and to start comparing and contrasting the fair implementation strategies of one community to another. And that gives us a starting point for the optimization of a fair implementation profile to hopefully establish, increase interoperability or increase in the use of resources, et cetera. So we think we can build smart and performant fair implementations by examining what others in the community are doing with their fair implementation approaches. I will skip this slide, but it's again just kind of restating what I mentioned, that we think by using FIPS in doing a comparative analysis and even repurposing a FIP designed in one context for maybe another related context, that we can kind of accelerate the convergence onto consistent, coherent, fair implementations that could drive interoperability much faster than if we didn't have this information available to us. And then, if you have built up metadata resources for your domain, if you have an overall fair implementation profile and strategy for how you're going to deliver this information, deliver your fair data, there's another component here, and that's how do you get your machine actionable resources into an operational context? How do you get them exposed to an internet of services that can come in and actually do things with this fair data? How can we actualize FAINR, or let's say operationalize it in a meaningful way? And that's where the fair data point comes in. And I think Yann has more to say about this. Briefly here, I'll just mention, from our point of view in this 3-point verification framework, that this idea of a fair hourglass has come in pretty handy. This is it's been a handy tool to help work with stakeholders in figuring out how to kind of progress through your verification in a more stepwise and coherent way. The hourglass is meant to represent your freedom to operate. So at the top and the bottom, you have the most choice available to you. At the center of the hourglass is where we might see the occurrence of some minimal standards for machine actionability. And we want to keep that as minimal as possible, thus the small waist of the hourglass. Going from the top down, you are free to create your data in any way you like, using whatever tools and methods that are appropriate for your domain. But that data may need to be verified. It may need to be made machine actionable according to some minimal standards. So that's this blue part, the top part of the hourglass. That's the verification. And the metadata for machine workshop, for example, can be a part of that. The lower part of the hourglass is what we would call the fair orchestration part. And it's where we get automatic data integration, data sharing, data visiting, and other kinds of analyses. And that first layer right below the center of the hourglass is what we might call the fair data point, or it's this point where your machine actionable encoded data and metadata are exposed to the internet, and agents and other systems can come in and start doing things with that. that first layer of that fair data point layer, there are emerging technologies now that are trying to address this this issue of getting your data operationalized. There's this classic idea of the fair data point itself and a specification and an implementation of that. But there are other systems out there that address more or less or one part of the equation or the other. But there are systems emerging right now that address this kind of this gateway to the internet for your fair data and metadata. And I have a document here that you can link to. It's just an informal document. I've been doing it with some others, but it's just to kind of keep a growing list of what I would call fair orchestration platforms. It's systems that can do some aspect of the FAINR functions. And then just a few more slides. I wanted to give then just an overview.
So if you don't mind, Erik, 2 minutes so we can keep up with time.
Yeah, no problem. Yeah, excellent. And I just wanted to make a distinction between data sharing and data visiting, because I think this helps us to understand better the potential role for like decentralized fair data point as a kind of a growing data network. And it's just to say that classically, when we think of data sharing, it tends to mean that there's data that is actually physically copied, and that copy is then transported somewhere else for analysis. So it's the idea, you know, I'm sharing my ice cream cone, I'm giving my ice cream away. And at least for sensitive data, this is always problematic because once your data is kind of like out of your control, even though there may be legal agreements around it, you never know actually what happens to your data. In the data visiting context, the idea here is that the data are in fact never copied, but the analyses are beginning to happen in a localized system. And so queries come to the data, and those queries have some sort of authentication behind them, and there's consent agreements that are in place that allow those algorithms to go as deep into the data as they are allowed. And then at least as these analyses are happening, that local information it stays local, and the data owner knows exactly what's going on at that data station. The other slides here are just showing additional examples of that. Some of them very advanced. For example, the swarm learning in Germany with the Swiss Personal Health Network. And with that, Yann, I will leave it there and say thank you, and I hope everyone will be faring well in the future. Thanks.
Thank you, Erik. Thank you very much for this very nice introduction to the work you're doing in GoFair Foundation. We have time for one question. Is there a question for Erik? Oh. I mean, maybe a comment. So what's interesting is when you start the FAIR journey, you don't know necessarily where to start, right? And I think the idea of the metadata for machines and the FAIR implementation profile is actually quite interesting, because it's a simple way to actually get in touch with your user base and the people that are going to contribute to FAIR, which means domain experts. So of course, in the realm of science, we're talking about researchers, but within any industry or organization, it could be even people from marketing and so on, so that they can define and start thinking about the metadata they could use to actually describe their data. And you can capture that throughout the workshop, because as we said, FAIR principles is not just technical, it's a lot of social aspects that you need to deal with. And the FAIR implementation profile is actually a nice way to capture community-specific implementation of FAIR, and they are actually RDF-based, because nanopublication is a RDF structure that encapsulates a triple with provenance data and a unique identifier that you can query as RDF as a graph. And therefore, you can start looking and comparing. So I think it's very nice. So again, thank you, Erik. So I will now jump into my presentation. Can you give me the right to share? Because with the incidents, please. And I'm going to talk about the fair data point, which is the third part of the three-step, three-point verification process. So, but I will place that into a context, a practical context that we developed in the project EOSC Pillar, and we continued also developing in Fair is Fair. So just to summarize, the fair data point is a specification, is an API specification for publishing fair data, right? And so what we still do not have the rights to share. No. This button is gray.
Oh, the speaker. I gave it to you personally.
Yeah, my German is rusted, so I'm gonna close that. And I think I need to share this one and then move this one. All right. Great. Do you see my screen? Good. That's the only thing you see now. Okay. And so that would be the last presentation of the day. And I think you've got enough of me already because I've been there the whole day talking a lot and so on. So here I just wanted to actually provide an example of how you can use also and leverage what's coming out from GoFair. And that actually try to drive the development of tooling and approaches to help verifying things by creating federated fair data spaces with the fair data point. And so that's work that's been done in the context of the project EOSC Pillar that just finished, and Tobias knows that very well because we used to work together in that project. It's been also used in Fair is Fair, and I'm going just to explain you and use these two projects as a use cases. But then I would like to start with a common, very simple example of why fair is important. So the real challenge right now, if you want to have a data-driven approach, is working with data. So if you're a data scientist or a computational scientist, you'd like to build data-driven models, you would like to use machine learning algorithms, but the main problem is, well, you need to work with data, and currently data landscape is an heterogeneous and distributed data landscape. And that's a real issue because you will need to use data from multiple databases, which all have a different API, all have a different metadata schema, and the internal model of the data is even different. So that makes your life really hard for data scientists, right? Because most of the time it's really difficult to find the relevant data. Once you've found it, it's challenging to have access to it because you don't necessarily know how you can get to the data. Data and metadata are definitively not interoperable, and therefore reusing that data for you is really time consuming. And these assumptions are both for working with data that are external to your organization, but also within organizations. So that's why FAIR principles are providing a sort of context and framework solution to enable that. Because the idea is, again, not just simple sets of principles that you need to apply, but it's transforming data into machine actionable units of information so that you can automate the process of working with the data. So basically, if FAIR principles were implemented everywhere, well, you would transform that heterogeneous and distributed data landscape into a fair data landscape where basically APIs would be harmonized, metadata schemas will be made interoperable, so you could easily access to any of the data. And of course, these data resources would be themselves findable. So you know where to get the data. Even if you just have access to the metadata, you will get the pointer to the data and the rules to access it. So that will make your life so much easier. Now, if we want to implement that, what does it require? Well, it requires to change all the databases, all the systems, so that we make them fair, right? So you need to change the data sources. And the problem is that it takes time and resources, right? So in the context of science, you have tons of data repositories. They don't have the money to actually make a change to the API. They barely have the resources to maintain the resource live. So you cannot ask them to completely change their API and their metadata format. So the question is, can we accelerate the adoption of the FAIR principles while reducing the cost of change? And so what we discussed in the context of EOS Pillar, because the idea emerged from that, is what if we could create FAIR data spaces on top of the existing heterogeneous and distributed data landscape? I'm sorry, something is wrong with the title. And so the idea is that you would create a sort of layer to which heterogeneous and distributed resources will connect that will allow you to actually harmonize the metadata descriptions, the API descriptions, for no cost, because it will just be an intermediate. And that's what we call the federated FAIR data space. And this idea emerged from the needs from EOS Pillar. In that project, we had 9 different use cases from communities that are very, very diverse. And some of these use cases, for instance, in earth science, they needed to aggregate data from marine, from atmosphere, from earth science. And so they needed to have a way to aggregate all that information for their purpose. And so we had also other needs expressed by these use cases. So the question is, how do we interrelate all these databases so that we can address the scientific questions that are driving these use cases and create on the fly these different spaces harmonized around the FAIR principles so that you can work with the wealth of data in these different repositories. And so the question that drove us during this project was, how can we build a service architecture that would support the aggregation and verification of these distributed and heterogeneous data resources without changing them? And so in order to answer that question, we started to look at what I showed in my first presentation yesterday. What are the technical considerations of FAIR principles? Well, you can summarize them very easily. You need identifiers. You need metadata and different type of metadata. You need a free, open, and universal access protocol, and you need licenses. Now, for many of these ones, we cannot do much because this is part of the data repository itself, if it attributes a global identifier or not, or if it provides a license. So what we decided to focus on is on the middle level, which is metadata, and a free, open, and universal access protocol. In order to work on this, what we looked is what are the existing solutions in the FAIR space that we could use and leverage. So for publishing FAIR data, you have the FAIR data point, which is a specification that was proposed by Luis Bonino and the team in GoFair, which basically specifies the format of an API for publishing linked data-based information on the API, structured around DCAT, which is the common metadata format used for publishing things. Then you have other tools that existed, like the Verifier or Semaphora, that are there for enriching the data or the metadata with semantics, so adding up some ontology information in there, and also some fairness evaluation tools. So what we decided is to start working on the central point, which should be the FAIR data point. So again, you can find these specification on the web. So you can look at this specification. The FAIR data point, basically, it's asking you to publish your metadata as DCAT, which is a W3C standard that's actually commonly used in open government data across Europe now, and to actually implement also some of the API functionalities that enable linked open data access. So basically semantic web-based technologies. And so right now the specification is working for DCAT version 2, but there is a release of version 3, so there will be certainly an update soon at some point. And so this specification were actually implemented. We had a reference implementation that was developed in FAIR. The idea was to demonstrate and work with repositories so that they could transfer and transform their metadata content and publish it into a FAIR data point, which was a dedicated service. Another source of inspiration is we have the FAIR data point, which is going to be our central database right? That is going to actually store metadata aligned into one common format. That's fantastic. Now, how do I get from the repositories, their content, with different APIs? How do I deal with the different APIs? And there's been some work that's been done in the Netherlands by Michel Dumontier and his team that's called Smart API that actually proposed to enrich with semantic description the Open API description. So Open API is now becoming a standard way of describing APIs, or at least generating human-readable documentation of the APIs, but it's based on JSON. So basically, it's machine-readable as well. So the idea was to take this JSON description that is used to generate nice web pages describing how your API works into something that could be used by a machine. So that enriching this API description will allow to create some smart harvester that will be able to understand how the API works so that it can get the content you need. And so with these different pieces of technology, we put them together into a simple architecture where basically, I don't know if you see oh yeah, you see it. So here is the data repository layer where you have various types of repositories. The idea is to create a sort of API federation by generating a smart API description of the APIs of each of these repositories that actually describes how you get the metadata content. Then these machine actionable description of APIs are used by a service that we called Metadata Smart Harvester, which is going to take this API description, automatically generates the query, and fetch all the metadata content from the different repository automatically, so that you will get all the metadata harvested from the repository. Once you have that, the next challenge is to transform this metadata, which is definitively not DCAT in many cases, and to map it to the DCAT profile, to the DCAT model. So you have an interface that allows you to do the metadata mapping that actually show you the structure of the metadata you just collected. And on the other side, you will have the DCAT schema so that you can actually directly map graphically the different elements of metadata. Once you have done that, with one click, you just transform all the metadata you just harvested into DCAT and publish it into the FAIR data point. So of course, the system provides different interfaces, one for repository owner to register their own repositories, and to data consumers, because the FAIR data point provides different types of API, a REST API, a Sparkle endpoint, so that basically you can connect also analytics tools to actually work with the metadata content that is harvested in the FAIR data point. So basically, easy deployment and scalability. The whole system has been developed for working for Kubernetes, so it's scalable. It allows you to create federated FAIR data space on the fly for various purposes. And you can select the database you want, just register them, and then whoop, you go, you get your catalog ready of data from these different repositories. What we offer in that system is that once you have registered your database once, you don't want to do the job twice. So basically, all the descriptions that you are going to generate can be exported into a machine readable format so that actually you can re-import it in another federated FAIR data space. So basically, in no time, you can create data spaces across internal resources, institution, domains, and basically create these spaces. You have no changes required for repository because you can work with what they offer already. You can help them making their repository content more fair, at least at the level of metadata. We're not dealing with data here, just the metadata. You have multiple APIs for accessing and processing the federated FAIR data space contents. And you can easily connect any processing service so that you can actually really use and work with the data you just aggregated. And so in order to register this, your resource, basically you have a simple user-centric workflow for repository owner. You start registering your data repository, providing some key metadata for the repository. You then register your API. So basically you could use Swagger, for instance. You generate your API description and you put it into the system, or we have a form that allow you to capture the different metadata call and formalize it into Smart API. Once you have done that, you click on the button, it harvests everything. And so once the metadata content is harvested, what it does, it actually calculates the mean metadata schema that you collected. So it identifies when you will have disparity in your JSON, for instance, to show you that you have errors and cope with actually edge cases. But also it generates this schema so that you can easily map it to GCAT. Once you have done that, there is another step that we added in the ESPR context, which is enriching metadata with ontology descriptions. And then once you're done with that, you just click on the button and poof, it's published on the fair data point. And then, of course, everything works as a microservice architecture, so you can add up more services. You can collect fairness evaluators at the beginning of the process and at the end of the process, just to show that actually you improved fairness. Of course, you can connect a UI on top of the fair data point so that you can search. And there is actually a UI provided in the reference implementation so that you can search and reuse the metadata, the data sets. Now, one of the challenges we faced in EOSPillar, and Tobias knows that very well because he was in charge in developing the semantic index, is, well, how do you get access to the wealth of ontologies? And especially the challenge in EOSPillar is that we are not focusing on one domain, right? It would be biomedical domains. I know all the resources, I have the pointers, I know where to find things. But how about agriculture? How about health science, right? Biodiversity. So we had to cope with a really large breadth of semantic artifacts. And so we needed to have a way to actually aggregate that content so that users can have quick access to the concepts for annotating the metadata that are corresponding to their domain, right? So that was the second question that we asked, is how can we make semantic artifact fair to leverage the wealth of existing semantic artifact to improve fairness of data? And so we're going back to fair is fair. I'm sorry, I did spend 3 years working on that, so I like to talk about it. But that was at the point one of the only recommendations we had for fair semantics, along some others that joined. So that was useful for actually setting up a frame. Now, you've seen that slide. Part of the work on verifying semantic artifacts was to actually evaluate the metadata that describes these artifacts. Whether it's in old file or outside of the old file, you still need to evaluate whether or not it's descriptive enough. So in Fair is Fair, we had this work on defining this minimum metadata. And actually, we used GCAT profile and MOD, which is a metadata for ontology description and publication, which is an ontology developed by Clément Jonquet and Biswana Dutta. Basically, it's an ontology that aggregates multiple existing ontologies for describing ontologies. And so they've done a huge, extensive mapping work, actually, right? Connecting all these different ontologies. And the idea was to create this profile, GCAT profile, that contains some of the MOD fields that are specific for ontologies. And actually, one of the things we did in Pascal's presentation, it was an old slide. It was in progress. Actually, we released that on GitHub already. We have an OWL serialization of the GCAT profile with the MOD. And so the idea was to try and test as a second use case to create a fair semantic space, right? If we can create a federated fair data space, we can do the same with ontology repositories. So the idea was to benchmark, and we did that both in Fair is Fair and in EOSPillar, is to aggregate the content from the different ontology repositories from the different domains. So Bioportal, AgroPortal, EcoPortal, MatPortal now, the Marine Vocabulary Service, the Geosemantics, I mean, many of these resources. And the idea was to test our minimum information, minimum metadata and GCAT profile, and then publish that into the fair data point. And the other was in EOSPillar to actually use this content to actually collect not just the metadata of the ontologies, but through the API, proper API calls to collect the terms that are in each of these ontologies, so that you could create a search index with Elasticsearch. You could index all these concepts, and I don't know how many concepts we indexed. Remember, Tobias? Like 10 million, something like this. It's huge. So we index them into Elasticsearch. And once you have them in Elasticsearch, what you can do is integrate that into the federated fair data space so that you can have an autocomplete function. So when someone wants to add keywords to the metadata in DCAT, it types in a term, and then it will automatically make suggestions of the concept with the link to the ontology and the repository it's stored in, so that you can actually have a fast way to access to that content, and you don't have to wonder, should I find my ontology on BioPortal or EBIOLS or whatever? I just want, that's my keyword. You know, I'm a scientist, I'm based on keyword. I don't care about the ontology. So the idea is to ease that process. And so basically, this is one of the examples on how you could use the fair data point as a way of federating and how to say, aligning different repositories and their metadata along one common schema, which is DCAT2, which fulfill one of the interoperability principles. I think it's EI1. Maybe Erik can correct me. And so basically, it helps a lot, the different repository. And that's my last slide. Do you have any questions? I think we have. Well, it's 45. Let's say we were a bit late from the start of the coffee break, so we still have 5-10 minutes discussions and room for questions, both for Erik, myself, and any of the remaining speakers. So questions. So I see Christina. Sorry?
Just a quick,
Oh, stop sharing. Yes, sorry.
Sorry, just a quick question to you, Yann. So you mentioned this, the fair data point. What I didn't get is, does it mean the repository I have, needs to become open, or does it mean I can download some blueprint and use it locally on?
So again, fair doesn't mean open. So it's up to you to share or not the access to the repository. So
Okay.
the fair data point is just a way for you to aggregate and align your metadata content with a common schema, right, which is DCAT. So, and you can keep it closed, which means you can, I'm sorry, I broke something on the Teams and widescreen is strange.
Yes.
So basically, this is just a database that you will use for publishing your content into one common schema. And you can add up several of the data sets from other resources that are open to that content so that you get a catalog of data sets you want to work with.
Okay.
Doesn't make it open. So you can close everything, you add a login, you can secure the API. So basically, on the reference implementation that was developed in Fair is Fair based on the specification from GoFair, basically everything was open, right? Because that's the point of the project, was to have this reference implementation for open science data. Now, we redesigned it because we are working on the federated fair data space in my company, and now we are securing the thing so that you can choose whether it's open or not, if you can provide access to API or not, but that should be your own choice.
Thank you.
Arco, you had a question? Or I think we lost the people on Teams. They are there? Sorry, guys, we don't see you. We just see a white screen. Strange.
Okay.
That was Alex.
Is my
making
voice
a
echoing?
comment.
Okay. Yeah, so it's really impressive. And then now I can see it in reality, something you mentioned probably year and a half back, like this really come into realization. I'll say that this is really great as a first step towards federating fairness, but then also probably now we can talk about like sovereignty and trust between the data spaces, and the fair metadata may be enhanced to include some of those information. For example, the I mean, some data in some repository, whether the data owner really wants to share it, or like what level of access they want to give on the data, what is permitted or not. And this will really generate probably a space for then like monetize data also. Like, yes.
I totally agree. So, I mean, one of the things that FAIR promotes is that you make your metadata open so that you can tell people, hey, I got this metadata. Doesn't mean you give away your data, right? So then there is the access protocol where, for instance, you can have patient data. You know that there is a cohort somewhere that deals with that particular pathology. And then when you arrive on the metadata, it should tell you the process on how to access. So you need to contact that guy and to go through that process so that you can get access to the data. And usually, if it's sensitive data, you cannot even download the data. You will have to have access to their platform to work on their platform. Yeah. Now, this is the next challenge: is how do you deal with these different access things? I think there's some inspiration that we need to look into from the marketplace perspective, because they're dealing with the same issues. But indeed, it's just right now it's just a way to create, in the end, just the catalog you want, instead of you creating your own search engine basically to retrieve the data of interest out of the whole web. And that's the value. And then, of course, you will be bumping onto the authorization and credentials needed for. Okay. Is there any question or anything that you would like to discuss? I have Monica that tells me that we need to stop because, yeah. Sorry, I don't see Alex. So, Alex, go ahead.
Yes, so basically I'm intrigued, and as everybody knows who knows me, I'm planning world domination. So when we kind of like look into the effort, what I learned today, everything with FAIR is good, yeah? How global is this? Who carries it? So is it more European effort? Then I can say, okay, I get all the Europeans on board and some more than others because they're more open, like it was with the cloud. For example, Scandinavia loved the cloud and Germany still says no, thank you. So when we look into the effort, how can we make it really global? So to formulate the question a bit different, is FAIR a European thing where Americans copy it somehow, or is it something that can go truly global? And so we have this ideal, what I dream, open innovation environment. And as Sylvia says, something is closed because FAIR doesn't mean open, but it can mean innovation.
Mm-hmm. So maybe I would leave Erik to answer that, but in the end, it's not just a European, it's worldwide. Erik, you're still around?
Yeah, I am, Yann. And yeah, it's a very good question. In the Go Fair Foundation, the GO is also an acronym. It's Global Open Fair. And so, yeah, we are in conversation with and kind of have communication with different regions, not just different countries in Europe, but different regions. So in North America, in South America, in Asia. And indeed, what we see is that the Europeans, for whatever reason, appear to be in the lead on kind of the level of maturity of FAIR implementations that they have available to them and kind of their aspirations. We do have some interest in America, I can say in the United States, that are using the advancements in Europe to try and kickstart or nudge other American interests to move quicker. So there's a bit of a kind of a farification race going on between Europe and the US. In April 20, for example, I will be in Washington, D.C. with the National Academies in a panel. And I think that was in part, bringing in the European just to show what's happening in Europe, to stimulate more conversation in the US. So I think Europe is in the lead here.
Yeah, because I thought so too by by seeing who is talking, which organizations are doing it, yeah. And I think it shouldn't be like made in Europe and we want to show somebody else how to do it better, not at all, because I think a lot of stuff what was discussed today is very beneficial to everyone, yeah, and especially data. So when we think about the open innovation process, yeah, so like when they built the Sydney Opera House, it was an open innovation. So basically, every architect could apply to build this, yeah, and this kind of like gives you a different idea because we have different upbringing. There's different educational systems. There is basically creativity can be formed in the place of where you brought up, you know, and by having such system is not like you want to say, okay, it's European, it's good, it's from the old world. It's rather something where we say it's very inclusive. Just take part and bring yourself in, because there's always at the end of the data some human that gives knowledge and consumes knowledge, yeah, and things like this. And I think this is what we should drive, definitely, because it's something we found out as a community, but I think it's beneficial worldwide, and it's good to hear that there is conversation all around the globe, because we noticed because I'm the mega stalker on the Commons. I'm looking after a document where I monitored in a legal way, where I monitor the ongoings with corporations. So we have, for example, what I call the Brazilian university. So we have some people from Brazil contributing and doing this stuff all along, yeah, and then kind of like bring in what they know to us and the other way around. And this is kind of like impressive when you say, okay, I'm there, I'm a commons, because commons basically mean everybody can come to push this further. And I really wish you well for your trip to the States, and I hope they listen to you and they join.
Yeah.
So yeah, maybe I will make this concluding remark. So FAIR is discussed also internationally for a long while. So Barent presented the actions of CoData, which actually is an organization that talks with the science associations around the world. And there is also the Research Data Alliance, which is also a very interesting forum because you get experts from all over the world coming to that forum to discover about FAIR principles, semantics, and all. And so basically the word is spreading. It's not going to be just us European against the rest of the world. Thank you very much, Alex. Thank you very much, Erik, on this. I will need to conclude, otherwise I think I'm going to die because we need to go for a social event now. I really would like to thank all the speakers for that session, for the tremendous job that they've done in presenting the